very active members on our education committee, Cody Wilson. Cody is area sales manager, market development leader for Owens Corning. And before we get to Cody's presentation, a couple of intro slides. If you want to move to the next one. Announcements, a couple of things coming up for your calendars if they're not there already. On the 27th, we have the ESC is making a presentation to the Austin San Antonio chapter of the Association of Energy Engineers. Vince Zubacek is going to be handling that for us, and that's an open meeting. There's not a fee to register, so if you're already a member of the Austin San Antonio chapter, you probably know about this and got the email reminder, but if you're not, you can attend that as a guest if that's of interest. And then the next ESC Texas chapter education webinar we have scheduled is in November 18th, same time, 11 to noon. And our speaker there is Juan Garcia. Juan is the principal contractor for SECO, the State Energy Conservation Office, on the Watt Watchers of Texas update and outreach initiative. And Watt Watchers, if you're not familiar with that, started off as a K through 5 energy education and engagement program for students, something that could be added to the classroom easily. And it's now been expanded. It's really a K-12 energy literacy sort of course and set of materials. This is available for free. The state of Texas through SECO sponsors and funds this. It is a great complement, sort of on the occupant side, especially in the K-12 environment, for projects that you and your companies are involved in implementing. Obviously, you're working with facilities managers and VPs and things like that on the facility side, but then you also need the occupants of the buildings to understand how to pull in the same direction and not inadvertently compromise the projects you've completed. And so Watt Watchers is a great tool to sort of bundle as part of the overall package. So look forward to that. And then the next ESC chapter meeting, Wednesday the 2nd, that's the full chapter meeting. So again, mark that on your calendars, and look forward to seeing everyone or hearing everyone for those upcoming webinars. You want to move to the next one? Okay, you want to take this, Cassidy?
Yeah, so the Texas Energy Summit is coming up. This is the a summit that is put on by the Texas A&M in engineering. Deb, what is the full name of that? The Innovation Lab, not the Energy Systems Lab. But anyway, it is a energy related conference happening virtually this year on November 10th through 12th and 17th through 18th. This is the conference that used to be called Cody, if you're familiar. ESC will have panelists on 2 sessions. On day 1, we will have 1 slot for the policies to promote smart, healthy, resilient, and emission-free buildings session. And then on day 4, which is the 17th, we'll have a panel on the policies to increase efficient use of energy and energy efficiency jobs. The outreach committee is working out who the speakers are going to be. That second panel is actually going to be sort of run by ESC, and we have a little bit more control over the agenda, what we're going to talk about, and who the speakers are. So we have 2 to 3 slots on that panel. And as I said, the outreach committee is going to be figuring out who is going to be the speakers for those, and they are meeting today at 1 p.m. To discuss these panels. So if you're interested in seeing how that shakes out, you might consider joining the outreach committee meeting later today. So yep, that's all on that. Deb, are you?
Yep, I'm here.
Okay.
So I guess we'll turn it over now to Cody. Going to switch over and pull up your slides. Also, we're recording this, so this will be this presentation will be recorded, and it will be on the ESC Texas chapter website for reviewing later, for sharing with your colleagues, and also that way you don't have to write down a bunch of stuff really fast. You can refer to it later. So Cody, take it away.
Great, thanks, Doug. Like you said, my name is Cody Wilson. I am with Owens Corning Market Development and Account Sales Manager. There's a little bit of background about myself. There's like, why is a salesperson talking about air sealing? And I've been in the energy consulting business for about over 20 years. I was in charge of 27 HERS raters in California and Nevada, worked with Building America projects for 10 years, teaching building inspectors and enforcing the energy codes throughout different parts of the United States. So I've been doing a lot of energy consulting for many years. When Owens Corning first hired me, I worked with our research development teams to looking for solutions for residential and for commercial type of solutions. We look at the energy codes and figure out which way they're going, and try to figure out solutions ahead of time rather than being more proactive than reactive when it comes to solutions and trying to figure out where to go. So that's just a little bit of my background. When we talk about, let me see. Uh-oh. All right, let's try this. All right. Little technical difficulties, I apologize. So basically what we're going to talk a lot about is air sealing. And when we talk about air sealing, it's really important to know that when you talk about any structure of a building, whether it's residential or commercial, how important the benefits of air sealing and controlling the air that's coming into that building, how it benefits everything that goes along in that building. So the building works as a system. It's not just, we sell insulation. That's just a small piece of what we do, but that's also a small piece of how the building comes together. You have to worry about HVAC. You've got to worry about ventilation. You've got to worry about all these different things when it comes to how many windows and how much sun is being exposed into the building. All this stuff comes together. So what we're going to do is, and the hard part with air sealing is trying to find all these little holes to air seal the building to where it's going to perform to the way it needs to perform. And so what we're going to do is talk about what some of those benefits are, not just to the person who's building the building, but the people who are occupying the building as well. What are the common issues that we normally see? I've been working on air sealing solutions with Owens Corning now for 7 years, and we've seen some different techniques we've actually invented. Wouldn't say invent, but we help create some different techniques out here with our counterparts who have been very successful in Canada, and we'll show you some examples of that. And then we're also going to talk a little bit about, where do you get the most bang for your buck when you start talking about not just air coming in, but moisture. Moisture plays a big part in where we live. So how do you manage that moisture, and how is air sealing playing a role in that? And how can you prevent that moisture from getting into the building and creating mold and all the other things that go along with the building? And then we've worked with a company called AeroBarrier. It's a new air sealing technology, and we're going to go into a deep dive of what this technology is. As a company, we do not have any financial ties with this technology. We just have done some extensive research in this technology and realized that, when we always look at what's the next step when it comes to how do we control indoor air quality in our buildings, this technology is pretty much what I consider a next generation of technology, and what we're going to be looking like moving forward on how we're going to be air sealing buildings. And this is just the beginning of what I see of this technology evolving. And we're going to go into that and kind of show you how it works. And there's some other benefits with this company, not just on the building, but even the ducts and all the things that go along with it when we talk about retrofitting buildings and things to that extent. And then we're going to just brief talk a little bit about ducts and how to keep them safe and how you can get the best performance out of your HVAC system in certain building constructions. And I do have a case study that it's a residential case study, because there hasn't been a whole lot of case studies on commercial buildings. But on this study, I mean, it's not a small house; it's 7,000 square feet. So it's the size of the small commercial building. But just to give you an idea of different pathways on, as a general contractor, if you're building a building, what you can do and how you can make it work all together without having it costing you an arm and a leg. So let's start off by talking a little bit about the benefits of reducing air leakage. The biggest thing that we always talk about with buildings, and whether in any form or fashion, when I talk about air sealing and I talk about buildings, it's all buildings. It's not just residential, it's not just commercial, multifamily. I mean, you name it, any building that is being constructed, all of these benefits come into play. But, you know, we're talking about dramatic heating and cooling costs, which most of you are aware of. Comfortability, and especially with condos, we're building units that are closer together, comfortable. And we talked a little bit about moisture. Noise is a big one. You talk about noise not just from the exterior of a building, but in between individual building units within a building. And the other one too is insects and pests and indoor air quality are really the big ones. Another one, and we'll talk a little bit about it, and what's becoming more and more popular, especially in multifamily and condos that are connected, is smell. Smell is a big one, and that's one of the areas where we're seeing more and more benefits, and people are talking more and more about not being able to smell what the person's cooking, if the person smokes next door, things like that. So that's becoming more and more of a benefit. We just recently did a project with an old historical building that had a restaurant in one building, and then the next building was a nail salon. So as you can imagine, the restaurant did not want the chemicals going into their building in the restaurant and being able to smell those chemicals from the nail salon. So when we talk about smell, it's a really important to be able to isolate that to where you're not smelling what the other company's doing or what your neighbor is doing. So we'll talk a little bit about the advantages of building air tightness and some of the disadvantages, because if it's not done right, then there is disadvantages. But we talk, you know, some of the things like we talked about, lowering energy bills, building comfort, energy efficiency, you know, all those things that we talked about. But the disadvantages is it can build condensation on exterior walls and windows, excessive indoor humidity, poor indoor air quality, stale and stuffy air, and also the development of mold and mildew. So, you know, the rule of thumb in any building construction is if you ventilate it, if you make it tight, ventilate it right. So the good news is, with all the disadvantages that are there on the bottom, there are solutions with indoor air quality and proper ventilation to prevent anything that's going on when it comes to building a tight house. I mean, dehumidification, great ventilation, all that solves the disadvantages. So there's really more advantages than there are disadvantages when it comes in it. And then we talk a little bit about, you know, we did talk a little bit about heating and cooling. And this kind of tells you about reducing air infiltration and correspondingly reducing the quality of air coming in versus air going out. And reducing heating loads is huge when we're talking about operating and equipment costs. The size of the unit that's going to cool off that building. And you know, the whole goal is to not let Mother Nature running in and out of your building, is to control how Mother Nature comes in and out of your building. And your HVAC system has to work really hard if you have unwanted air. In some commercial buildings, there's not much you can do because you've got people walking in and out of your building. But if the people are walking in and out, and you've got good weather stripping and things like that. But when you do have people working in the building and there's not a lot of foot traffic walking in and out, the HVAC equipment plays a huge role on the indoor air quality. And indoor air quality is becoming much more of a talking point now with COVID and everything that's been going on with indoor air quality. So we're seeing different changes of the way not just indoor air quality is being addressed, especially when it comes to air sealing, but even how some buildings are being constructed. Because prior to this year, most of the buildings and condos and things like that, we had businesses on the bottom and apartment complexes on top, and they had resort style buildings. Well, some of the new designs that we're seeing here is that the people don't want to be piled on top of each other right now. So they're changing that construction, and they're changing the way they're doing this to where you're going to have apartment complexes or condos, but they're disconnected and they have a little bit of property of space to each other. We're seeing that type of architectural designs coming now into the new commercial type condo buildings. So even the way we're building now, COVID has made a huge impact on how we're designing our buildings. So, and that's just as important on a small building that's connected to each other than it is from a building that's not connected to each other. I mean, you got to have good ventilation, and in the amount of maintenance that it takes to on an HVAC system, it doesn't matter what type of system it is, whether it's cooled or watered or a very large, conventional system for cooling, even on like freezers and things to that extent. It's all goes down on the maintenance. So there's different ways of doing that and having proper filtration. And if you have a lot of vents coming in and a lot of dust coming in, your system's going to work twice as hard. So the amount of maintenance that goes with the HVAC equipment, how much of an impact that air sealing plays in there. I've already talked a little bit more about the indoor air quality. And if you do want a copy of this presentation, I will just let everybody know, and I will send you a copy of this so you can have it as well. I know this is going to be recorded, but if you do want to have some reading information or some reference points, feel free to contact me. My information will be at the end. So I just wanted to give you an opportunity to know that. But when we talk about, I did talk about smell and indoor air quality earlier, but there's a study that was done in Minnesota that 50% of the renters out there said that secondhand smoke gets into their apartment from elsewhere other than the building. So these are just some of the things to verify and to validate some of the things I talked about earlier about smell. And it makes a big, huge difference when we're talking about going from whether you're living next to each other or if it's from building to building. And, you have unique companies that are next to each other, and it can affect the way their business is being done if they're connected. So we see it all the time where you have certain companies, whether it's a restaurant or something connected to another company that has a lot of odor, like I said before in that example with the nail salon. But the hardest part, it's hard enough to isolate a building that you're constructing. It's even harder to do it on a retrofit in an existing building. So that makes it even more difficult. And so how do you get to that? So we're going to talk a little bit on some different techniques of how to air seal, not just new construction buildings, but also existing units as well. And then we also talked about thermal and vapor issues. Whenever you have air moving through a building or moving through a wall, and you're mixing that with humid air coming into a facility with cold air, moisture can build up. So the hard part is how do you manage that? I mean, we have tapes, we have vapor barriers, we have these other things. The hard part is where do you put it on the building? So you still want the building to look aesthetically nice, but you also still want it to perform. And out here in this particular climate zone, especially in other climate zones where it's extremely cold, but managing the vapor and moisture from the exterior of the building going into the interior helps. So you don't have to work as hard on the inside of the building when you're managing moisture than you are if you put and manage it from the outside of the building. So when we talk about maintenance, we talk about all the things that go along with the inside of the building. If you do more management from the exterior of the building, you will have a better opportunity to manage that moisture from the exterior than you do from the interior. These are just some examples of what we've seen out in the market when you do poor moisture penetrations. I mean, this is, we look at this as moisture prevention, but it's also controlling air movement through the envelope. And this area right here kind of gives you an idea of one small hole, how much moisture can come through a wall and how much damage it could do. So we always talk about the indoor air quality piece of this, but in a hot, humid climate like we live in, moisture can do more damage than anything, and you'll be spending a lot more money than dealing just with uncomfortable units. So there's just different ways of doing this. And, here's some examples of poor moisture management at a school, and you can see the flooring just lifting here. And that's all due to improper balancing, moisture buildup, air movement coming through that bottom of that area. By using continuous insulation from the outside, whether it's XPS or any type of polyurethane insulation board, it really doesn't matter as long as you're putting some type of protection from the outside of your unit and then taping it and sealing it, properly flashing around the windows. All these different things come into play. And so it's helping preventing the moisture from coming in the building, but it's also you're also getting a better performance unit, because depending on, and I got some pictures in here that I'll show you, but here's a picture of a unit or an apartment complex or bedroom or any type of building. And this looks particularly normal. But when you look it through infrared, this is all thermal, and it's all air moisture right up in here coming through the top plate. And that's going straight down the wall. And so that's all air coming into the house. And this is thermal. And this is all conductive, and this is all conductive, and this is all convectional. So there's so much stuff going behind this wall that's happening that nobody knows about. And this happens in every single building. If you don't have proper ventilation, and if you don't have proper air sealing techniques, this all happens in every single building that we have. And we talk about preventing not just moisture, but thermal performance. Well, here's a picture of these two houses here are just used with regular siding or whatever you're putting on as far as your cladding, with no type of insulation on the exterior. So you can see all this yellow is all wood. So if you're doing a wood framing, you can see it as clear as day, because you also have to realize that wood and even metal wood has an R value of 1. As to where metal is even worse, because it absorbs heat at a faster rate than wood does. So you take that and you look at your wall cavity, and for instance, let's just say this is a 2x4 wall cavity. The most you're going to get out of a 2x4 wall cavity is an R15. And so let's say this is an R15, and then that yellow streak is an R1. You have an R15, and then you have an R1. So if you take this whole wall assembly and look at the total R value in a 2x4 cavity, you're really only 22% of buildings are made of wood or metal when it comes to construction. So you're really losing 22% of your R value in that overall performance. And I haven't even touched on the windows. The most efficient window out there, on a regular basis that's being installed, windows are usually done using U value, and all U value is R value divided by 1. So if you ever see a window that has a solar heat gain coefficient or a U value number on it, just look at that U value divided by 1, and that will tell you what the R value is on a window. And the average window is about an R3. So you're already losing 22% of your R value on the wall, but because of the framing. And then depending on how many windows you have on this house, you're only getting an R3 on the window. So if you have a building, especially some of these commercial buildings where you're seeing 80, 90% windows. So, I mean, if you got a building that's all windows, you're reducing your R value at a huge disadvantage right off the bat. I mean, if you got 60% glazing, you still got to make up for that, and windows leak. So if you don't properly flash these windows correctly, you're going to have air leakage coming in, depending on your building, and you're going to have a very small R value because you're using windows that have a very small R. So comfort and air leakage and sun that's coming into a building all play a big matter on how well that building's going to perform altogether when you talk about ventilation and everything. So this is just an example of what I was telling you about with the continuous installation on the outside and how it helps slow down that thermal bridge. So you have your typical R value, but if you put that continuous installation on the outside, you'll see here that you're going to get a higher R value, an effective R value than you would if you didn't. And this is with a 2x6 cavity. In a 2x6 cavity, you're right around an R19 in some cases, unless you blow it in. If you blow it in with fiberglass, you can get an R26. But typically, you don't see blown in walls in commercial buildings unless it's underneath the subfloor. So typically you're putting like an R19 in that wall. But if you don't slow down that thermal bridge on the outside and slow down that heat transfer, this is about what you're getting, as versus putting continuous insulation or some type of foam on the outside of that house to slow down that heat transfer. So let's talk a little bit more now about air sealing and why it's so difficult to air seal buildings. The hardest part really is the amount of trades that are involved. You've got your framers, your HVAC contractors, plumbers, insulators, electrical people. All these people are they're all responsible when it comes to air sealing. Back in the day, people, these HVAC contractors or plumbers or electricians, I call it the Chuck Norris approach. They'll kick down a hole in a wall to put a wire that's about a half inch thick, and then they're expecting someone to come in and try to air seal that. Well, those days are gone. I mean, everybody's got to be responsible when it comes to trying to air seal a building and making sure that if you're going to cut a hole to put something through it, that it fits. You just can't go in there and put a big, huge hole in there and having one wire going around it or a duct or whatever it may be. So having the different trades makes a big hit, and holding them responsible makes a big difference. And then we talk about materials. I mean, as a GC or anybody that's trying to build these buildings, and even architects, they have people like me walking in there saying I have the best thing since sliced bread, and there's 200 of me coming in there telling them that I've got the best solution. And as a designer, as an architect, and as a general contractor, I've got to figure out which materials are going to be the best for my building, and how am I going to do it. And really at the end of the day, I have a budget, and I have to minimize risk, and those are the two biggest things that a GC or a contractor or a architect's looking at. They're looking at is it within my budget? One, and two, is there any risk involved in putting this product in my building? And so, and trying to find what that right combination is the key. And it's hard for anybody to know, because there's so many different types of solutions and ideas out there. So they rely on consultants to come in and say, look, what do you think about this? Does this work? Because these consultants that go out there and look at this stuff, they're the ones that are seeing it working on a day-to-day basis. So they have to rely on a third party or see something out there that's got to be proven in order for them to take that step to putting that solution into their building. And the other part too is knowing where to air seal. I mean, there's tiny little holes throughout this entire building. And do you have to plug up every single tiny little hole and try to find it? No. But what you want to do is you want to find where you're going to get the best bang for your buck and where you're going to spend the time air sealing that building, so you're going to get the best results possible. And that's the hard part, and knowing what that is. The other part too is it's unpredictable results. You really don't know at the end of the day until that building or that structure is finished. If you go and test the air leakage on that building, you're not going to know until the building's almost finished. So how are you going to go in there, and if that building's leaking and a contractor missed something after the fact and after the building's almost finished? You're not going to go back and turn the building over and reconstruct it. If there's air leakage missing, you're going to have to try to figure out how to do that afterwards. And there's ways of finding out. I mean, we've filled up buildings with the actual fogs and smokes and looked for air leakage and things like that. There's ways of doing it, but trying to fix it is the hard part. So getting it right is what really matters. Understanding not just the envelope leakage, but your duct leakage and all the things that go along with it, and the economics to seal. So we've done extensive studies when it comes to most effective places of air sealing. Now, I will say that most of these studies have been done on residential buildings. Recently we're starting to look at air leakage in commercial buildings. Multifamily has gotten hit with this more recent than larger buildings. But looking at the energy codes on where it's going and how they're moving forward, and I'm already seeing it in California. I always look at California because whatever California is doing, the rest of the United States will be following in the next 5 to 10 years. That's been a trend since I've been in this industry. And being in California and even helping writing some of the energy codes in my prior days, looking at what they're doing towards commercial and green building currently, you're going to start seeing air leakage and testing like that. It's going to start being effective with commercial buildings, and in some cases it's already happening. But when you look at areas of where to air seal, as you can see, this is just a guide, and I want to say that right off the bat, because depending on how you construct your building is going to dictate these numbers. And the reason why I say this is because we did an extensive study, but if you look at the bottom one where it says sill plate to foundation, and it's the least effective. Well, in some cases, I've been to buildings where the sill plate to foundation actually leaks almost one air change. So, and that's because of the transition from your framing to your concrete. If it's not good and you don't have a sill plate or anything like that on the bottom, it can make a big, huge change. But the ones that are up on the top that you're seeing here, those are ones that are more consistent no matter what structure you build. So this is really a guide, and you have to really know how you're constructing that building to know where to really air seal. But these top 5 and 6 areas, no matter what construction of a building, makes a big, huge impact on the air leakage, on where to air seal and where you need to focus on. So, top plates to attics, duct boots, recessed can lights. Now, recessed can lights, the technology has gotten a lot better within the last 5 years, with the LEDs, but in certain buildings. Some buildings are not using any types of these lights, but lighting and penetrations through lighting, depending on how it's constructed, is an area that you do want to focus on to make sure that you're sealing it properly and you're using the right proper materials to air sealing around lighting, because of how hot some of the lights can get. So knowing the proper way to air seal and where to air seal when it comes to lighting in a building and how it's being constructed. So you do want to look at that. You look at rim and band joists, on the exterior of a 2-story building going to a 3-story building. those are very huge leakage points. If you have a garage or even a parking garage that's connected to a construction building, most of the times I see that they're completely different isolated walls and it's not an issue. Some cases it's not, but you do want to make sure that any garage or exterior or common wall going from one unit to the next, that makes it even harder when you're talking about multifamily, because anything that you put on that multifamily wall that's fire rated, and you add anything to that fire rated wall, you have to have it tested. So you can't just add certain things to a fire rated wall and say, okay, I'm going to air seal it, but now it's going to affect the fire rating and the building departments aren't going to pass on it. So it's really hard, and you got to make sure that you design those common walls to where you're not having leakage going from one unit to the next. So I don't want to go into the weeds to all these, but when you talk about different types of corners and all the things that go along with it, there's a lot of different areas, as you can see here in a building, that affect on how you air seal. So one of the things that me and the building science guys were looking at is like, this is, not a simple thing to do. What can we do to minimize what type of and how we air seal so we can hit all these areas, and so we don't have to focus on every little single area of a building? So what we said is like, well, if we air seal from the exterior of the building, and it doesn't matter how big the building is or what type of building it is, if you can air seal from the exterior of the building, then now you're really actually hitting all the joints from the inside. And so if something gets missed from the inside, it's air sealed from the outside. And Canada has done an amazing job of doing this with residential and commercial buildings out there. And so we said, well, we know they build a little bit different in Canada than they do out here in Texas and different parts of the US. So how can we take what they're doing and apply it to the way we build in different parts of the United States, and especially out here in Texas? And so what we did is we created a gasket that looks very similar to seal. And this video will give you an idea. Now, again, this is on a residential building, but we've done this with commercial as well, but with this animation. But if you look at the framing of the house, and oops, sorry, let me mute the speaker there. And what we did is we just took a gasket and we picture framed the building. All you're doing is picture framing the building to the outside with a flexible gasket. And once you do that, it doesn't matter what you put on the exterior of that building. So, or how whatever your cladding is on the outside, it doesn't matter. If you gasket from the outside and do that, now you're stopping all the penetrations. So as you can see, it really doesn't matter how you're constructing the building. All it really matters is where you put that gasket to stop the air leakage from coming from the inside to the outside, or I'm sorry, from the outside to the inside. So this is a very effective way, and this is just showing you one set of cladding. So it really doesn't matter what you put on the outside of that building. Now you've stopped all the penetrations from the outside coming in. And then when you're on the inside of the building, there's different ways that you need to air seal from the inside as well. But, there's, penetrations from the top plate using that same gasket. You see this a lot on residential, but at the end of the day, you're just doing the same exact thing, and you're picture framing from the inside on areas of your building. And then when the drywall or whatever you're using on your interior goes up, you're actually stopping air leakage from coming from the inside, from the top of the area of the building, from the inside of the building. So really your main goal is to stop airflow from unconditioned to conditioned area. So how do you simplify that as much as possible in order to go in there and make sure all those areas are done correctly? And again, this is residential, but the same thing applies in commercial. It's the same type of concepts. And we've seen these concepts work in commercial buildings. Schools and things to that extent, maybe not as much. But the top plate penetrations and trying to stop air leakage from coming inside, yeah, we have seen it on those type of buildings. And it's a little bit of a different practice, but there is a benefit to it. And so, you know, this technology, it works. We've seen it. It's proven. But at the end of the day, it's still a lot of work, right? And that's when we started looking at AeroBarrier and this new technology. And it's like, well, how is there any way to simplify this more without costing an arm and a leg? Some builders are going to spray foam and some other types of air sealing solutions, but it's expensive. And there's no guarantee that even with foam, there's no guarantee that you're going to get the air sealing results that you're in there. You know, they'll give you a range of where you should be, but there's no real guaranteed results until we saw this technology. And this technology started about 20 years ago with duct sealing, and they still do it today. So basically, take an existing duct unit, air seal it from the inside. And so they said, well, we can do that. Why can't we do that with a building? So they've been doing this type of technology with ducts for a while now. Back in 2010 is when they first started doing it with ducts. Basically, it's acrylic-based sealant. And so we're just going to go into and show you a little bit how this works. And I'm really hoping that this works. Okay, it worked. All right. So I wanted to show that to give you an idea. I mean, if you look at the way that building was done, that building was done pre-insulation. You can see that it was foamed in the wall. But what's nice about it is that it really doesn't have to be done at that stage. It can be done after you've insulated it, after you drywalled the unit as well. So there's different, that's what the really nice about the versatility of this product and what it does. It really completely simplifies the process. Everything that we've talked about prior to this of us looking for the holes goes away because the machine does it. And one thing I've learned in the years of doing different type of air sealing in buildings is that your air sealing solution is only as good as the person who's installing it. And you're relying on humans to go in to do the technology and the air sealing for you. And we all know that with labor and all the things that are going on through construction, things get missed. And we understand that. I mean, it's just part of the construction business. But this technology avoids all that because all you have to do is prep the house, and the computer and the sealant actually finds the holes for you. So once you pressurize that building, and you can pressurize up to a 16,000 square foot building. So once you pressurize that building, the sealant finds the hole for you. And so, you know, you're doing your installation, and you can do this at drywall. You can do it at the beginning stages before drywall. As long as you can pressurize a building, this product will seal the building for you. And if you look right over here to the right, it actually it gives you a report, and it will tell you within a half an air change at any stage of this area, how tight your building is going to be when it's done. It's a really interesting technology. The mist, the AeroBarrier guys don't like when I say it, but it's basically fix a flat for your house. You know, you're pressurizing a building, and the system fills it for you. And just to give you an idea on how quickly this fills out, we do this on a lot of our demos. So we'll cut a hole, and that's about the equivalent to maybe 1 air change per hour. And all there is a screen there. And just to give you an idea that screen's empty, let's see if it's starting. Yeah, so that's an empty screen. And basically that's a visualization of the holes in your building and how quickly it fills up a hole. And you can see that from the outside of the building. And so it gives people an idea of how quickly it goes in and air seals. Now, you can go as tight as you want. I've seen buildings less than 1. I've seen buildings at 0.03 air changes. I've seen buildings where they did hospitals where they have to be airtight from room to room. So they'll go in there and isolate each individual room and completely air seal it to where you got no air leakage coming in and you get proper ventilation. I've seen it done on commercial buildings. The ones that I told you about, the nail salon next to the restaurant, they pressurized that one building and completely isolated it from next door, and now you can't smell anything. So as you can see how quickly within a minute it seals up that building. It looks for the hole and it seals it. A perfect example is a multifamily project out in New York. They were having very serious issues with trying to get the house, the units tight. They were right around 9 air changes per hour. And if you really want to get an idea what a 9 air change per hour is, if you take every hole in a unit and put a 23-inch screen television, look at the size of that TV, and that will tell you how big of a hole and how much air is coming through your house and through your unit. Now take a look, and they dropped it down to 1, and go ahead and take a look at a business card, put it on the corner of your 23-inch screen TV, and that's how much air that they've actually stopped from coming in, because that's about the equivalent to 1 air change as a business card. And that's what they're doing in every single unit in this multifamily building. As you can see, they're in the hallway and they're isolating each individual unit and air sealing it. And they can do that with any commercial building as well. And you tell them how tight you want the building, they turn the machine on and the machine does it for you. Now, the cool thing about it is that none of the product will stick to the walls. It will have a little bit of a residue that comes down on the floor, but within about an hour, you won't even know that it was even in there. It really just depends on how humid it is outside, but it dries very quickly. And then you can put any type of flooring, carpeting, or whatever it is on top of it, and you wouldn't even know that was in there. In some cases, you don't even see this product when you walk into the unit or into a building, because it's going behind the walls and sealing everything that air can go through. It hits the first point of contact and completely air seals it. So if it can travel to a hole, it will pick it up and it will seal it. So we've talked a little already on the multifamily buildings, and then here on commercial buildings. So they've done systems, like it says, they can put 16 nozzles and go up to 10,000 square feet at a time. So if you have the ability to isolate a floor or an area of a commercial building, this could air seal it. And if you're doing a remodel and you're reconstructing a building and you're going into an older building, they usually kind of somewhat gut it anyways. And you can do this on existing buildings. We've seen it done on historical buildings. We did one in Chicago that was about 16 air changes per hour, and they remodeled it. And they went in and air sealed it and brought it down to 4 air changes. And that building was built in 1920. So it really doesn't matter how it's shaped, where it is. As long as it can be pressurized, it can be air sealed, and it just completely simplifies the air sealing process to an area that I've never seen. And I've been doing air sealing for a long time, and I've done about 30 of these myself on presentations. And the one thing that really, they've done over 40,000 of these in the last 5 years, and not one has ever failed. That alone pretty much sold me in every single one that I've done. And, why do I like this product so much is that when you use fiberglass insulation in my business, we bring you the highest R value per dollar. Fiberglass gives you the highest R value in a wall cavity per dollar. The problem is that our product is a filter. It doesn't air seal anything. So if I can find a simple way to air seal a building, use an inexpensive product to give you the R value, now as an architect or a person who's building a building, I'm giving you the best possible way of air sealing. And I haven't even touched, this is just a small fraction of some of the stuff that I've touched, but let's talk, we haven't even gotten into fire. I mean, anytime you go from one building to a next, what feeds fire? We talk about fire rated walls. It's oxygen. If you prevent oxygen from going from one area to another, you can suffocate or slow down the heat transfer of fire from one building to the next. So you talk about a fire rated wall. Well, this is a sealant, so it doesn't have to be added to a fire rated wall, because all it is caulking, basically. So what this product does is it's an acrylic based sealant. And it's been EPA tested, and it's been green gold certified. So the biggest thing for us was, is this product safe? Now, do you want to be in the building when it's being sprayed? No. Nobody wants to be in the building when you're spraying paint or anything like that. So, but once it's done and the building's done being sealed, they open up the windows and it dissolves right like 1 foot outside the window. So the question was it safe for the environment once it goes out in there, and it's passed all the EPA certifications, and they can give you all those certifications if you want. We do have, when I first did this, we had one installer that has 2 machines out here, but there are other installers now in Texas. And it doesn't make a mess. I mean, again, you won't even know that it's being done. And it takes about, and once it's done in about 60 minutes, like maybe 20 minutes after they're done sealing it, any trade can come in and do work afterwards. So that's, I mean, a very simple thing. And some of the buildings, and we've been talking about in residential, and now we're starting to see it in commercial, is just basically laying your truss down and burying ducts over it to get a better performance on your unit. And just to give you an idea of how well this performs in an attic, and we've seen this, we've done these in retirement communities, which is also with the AeroBarrier and the buried ducts, different types of commercial buildings where they still hang ducts underneath the roof, and rather than just dropping them down and burying insulation. This is a graph that I'm not going to get too much in the weeds in, but right here, just to give you an idea, is your ceiling. This is your duct air temperature, and this is what's going on in your attic and all the different service areas. So the time that the air comes out of your air handler, it's at about 55, 52 degrees. And we did some with a 200-foot run in the middle of summer. The attic was right around 120 degrees. And we saw a 2-degree temperature difference in green is the actual duct temperature, and that's the surface of the outside of the area. So you're only seeing a 2-degree temperature gain from the time it comes out of the coldest part of the air conditioning unit or the unit going to the area where it's supposed to go to keep that building comfortable. And so, and it's not costing, and it's costing the builders and the contractors less money to do this, because, and we're lowering tonnages, and it's not, and we're filtering the air coming in, and we're making it airtight. We're filtering the outside air coming in using different types of ERV types of systems that minimize outside air temperature and quality of air coming in to circulate through the unit. So you're talking about less maintenance. And to give you an idea, and again, this is a residential home, but this house was 6,500 to, I think about 7,000 square foot unit home. But if you're not familiar with the HERS score is a way for a building to find out like your miles per gallon for a car. So, and this is kind of like your golf score. The lower the number, the better. So a unit or a building that was built in 2016 is considered a 100. And going below that, you can go down to a 0 by using renewables. So, and this goes for, you know, they don't have this type of system yet really for commercial. They do some certain stuff with lead and other things like that, but this just kind of gives you an idea of what a builder did and didn't cost him any more to do it and his performance. And so they were putting their ducts in conditioned space, 2x4 wall cavity, R13 in the wall, 22 under the roof deck. This was their air changes per hour, tankless, 16 SEER units, and these were their windows. All we did with this builder is go to a 2x6 wall cavity. We blew in the walls. We put continuous insulation. We did not put their ducts in conditioned space. All we did was put an R49 on the lid, same tankless water heater, a little bit better energy efficiency rating. And this building is actually performing 15% better than what they were currently doing. And this side of what he did is not costing them any more than what he was already doing. And the reason why I show this is just to let you know that there's different pathways when it talks about the overall performance of a building. And there's different ways of doing it, and that's not going to cost you much. That also reduces risk. And this is just an example of a residential building, but if you look at large buildings, multifamily, in different ways, is just showing you that there's different pathways to get where they want to go, and it's not going to have to cost them too much to do it, and it minimizes the risk, and they're getting a better building, less operating costs for the people who are running the building, and which also, you know, when you talk about operating costs in commercial, you're talking about margins, and you're talking about being more profitable when you're paying for your operating costs. So if you reduce operating costs, you're going to be a more profitable company when you're operating that building. So that's why we have LEED certification and other programs in commercial buildings. So this was just an example to give you an idea of different ways of doing buildings. And we're seeing more of these residential style commercial buildings being constructed in certain areas. And we're seeing the residential type of codes going into commercial, and it's going to make a huge impact, because I've already seen architects that are being forced to come in with different energy code stuff that they have to do. And then I get calls from my customers that the architect and the general contractor says that they have to do this. And they put it in their architectural plans, and they don't understand what trade's supposed to do what. They just automatically assume that if it's air sealing or something that they need to put onto on a building, that is automatically one certain trade that needs to do it. So education, when we start seeing these type of codes going into commercial, is going to be a huge impact, because they're not really going to know what to do. And so that's where we're trying to help as much as we can. With that, I'm going to, here's my contact information if you'd like a copy of this presentation. And we will go in with some questions.
Thanks, Cody. I've got a question. I typed it into the chat. Don't know if you've seen that yet, but for a commercial application with the AeroBarrier, I assume that's priced like on a square footage basis, or is that
correct?
Okay. What is the typical range, and how do you calculate, or if you're calculating payback or looking at ROI, I think is important. How is that done?
Well, I would say the cost, it varies on the size of the building and on the prep. But I would say you're anywhere between, in its living area. So you're anywhere, I would say, between 70 to 90 cents a square foot.
Okay. And by living area, you're talking about, I guess, conditioned space.
Conditioned space.
Yeah. Okay.
Conditioned area.
Okay. And the sequencing of it, it looks like, I guess in a retrofit scenario, if you have the space empty and you're doing other work, that would be sort of the ideal time to do it.
Correct. And it really depends, like if you're redoing the flooring, because really the only place where the product will go is on, it goes down to the flooring. So, so that will also affect, the prep. So if it is a remodel and they're doing all the stuff afterwards, and they're going to be putting, a complete remodel inside that building, then the prep really is just going around the windows. Yeah. Because we know the adjustable windows leak. And we also put, they also put things inside the ducts so it doesn't go through the duct system. And things like that. But for the most part, the prep would not be that hard to do on an existing building, depending on what stage that building is in. And you also mentioned the ROI as well. So the ROI is really going to depend on, one, how much are they currently spending now? So we'd have to look at the history of what their utility costs are. What other measures are they doing other than air sealing to help the overall performance of the building? And, are they going to putting in new windows? Are they putting a better HVAC unit in? Or are they going to blow more insulation in the attic? All those things are going to come into play. And that will help you get an idea of what your estimated costs are initially versus what the change is. And that will help you with your ROI.
Okay. Do you know the material that's used itself? You mentioned applications like nail salons and restaurants. Is the material itself susceptible to any particular kind of chemicals or anything that would cause it to deteriorate?
No, we actually took this product and brought it to our own lab. Because if we were going to promote this product with our customers, we wanted to test it on our own. So we've done our own testing in our labs, and we've done 50-year testing on this product. And the beauty of it, it expands and contracts with the building. So like most caulking that you put on a building, once it dries, it cracks. So once the building settles or moves, it cracks your caulking. So long-term, you're not going to get the long-term solution on typical caulks and sealants. With this product here, it will not crack. Matter of fact, when you saw that sealant on the screen, I can take that screen off and move the screen all around, and it will not crack that product.
Okay. Interesting. Yeah, I was familiar with the duct sealing application of that, but didn't realize they had expanded it to.
Yeah, the technology of the sealant's a little bit different because it's going on a different area. as they're doing it with the ducts. And one of the things that we saw with the ducts versus the house, it has, we saw some certain things in the chemicals that we didn't particularly like, or they didn't like when it came to trying to seal it to a duct system versus the inside of a house. And so they've kind of tweaked the technology with this product. And like I said, we took it through the EPA testing ourselves and found that it's extremely safe once it dries. There's no off gassing. It's just like, if you think of like an acrylic low to no VOC type of paint, it's the same type of sealant.
Okay. Good to know. Any questions from anyone for Cody? Hearing none, seeing none. Well, thanks for joining us today. The recording of this, we'll have it on the Texas ESC website, and we'll provide a link to that. And then, as Cody said, he's got his email here. If you'd like a copy, just send him a note and he'll get you the slide deck. So with that, we will conclude for the day. And thanks for your attendance, and look forward to having you participate in the next ESC education webinar.
Thanks, everybody.